Hello students, how are you all? I hope all of you are doing amazing. So welcome all of you at AriserTalent, and in our last lecture we have a discussion about few of the questions of the NCERT that is related to our chapter atoms and molecules. Now we are continuing with this next same questions, and the further questions in this sequence are, this will be our question number 7. Up to question number 6 we have completed in our last lecture. So, the question number 7 is, what is the mass of 1 mole of nitrogen atom? Now, we are going to do some questions which is basically dependent upon the mole concept. So, mole concept is the another important part of this chapter, and we have a great discussion about this in our previous lectures also. So, 1 mole of the nitrogen atom will having a mass that is exactly equal to its molar mass. So, 1 mole of N2 atom have a mass which is equal to its atomic mass, because 1 mole of any compound will having a mass that is exactly equal to its atomic mass. So, for the N2 atoms, if I am considering that nitrogen is having a atomic mass 7, so for the N2 what we will get? We will get 2 into 7, that is equal to 14 gram. So, what is the mass of 1 mole of N2 atoms? The mass of 1 mole of N2 atoms will be 14 gram here. Okay. Now, what is the mass of 4 mole of aluminium atom? So, 1 mole of aluminium atom will having a mass exactly equal to its atomic mass. So, again I can write here 1 mole of aluminium atom have a mass exactly equal to its atomic mass. And what is the atomic mass for aluminium? It is equal to 27 gram. So, we have 27 gram. Clear? So, you have to identify the mass of 4 mole of aluminium atom. So, 4 mole of aluminium atom have a mass that is equal to 27 into 4. Clear? It will be 27 into 4 and it is equal to 108 gram. So, what is it? It is equal to 108 gram. So, 1 mole will contain a mass that is equal to its atomic mass, but 4 mole of the atom will contain a mass that is equal to 4 into 27 and it came out to be 108 gram. Now, you have to calculate the mass of 10 moles of sodium sulfite. So, 1 mole of sodium sulfite will having a mass that is equal to its molar mass. So, firstly we will calculate the molar mass for Na2S2O3. So, the third part here will be molar mass of Na2SO3. Now, sodium is having atomic number 11, so its mass is 23. So, it is 2 into 23 plus 32, and oxygen is having a mass of 16 gram. So, it came out to be 46 plus 32 plus 48. So, it will be equal to 46 plus 80 and it will be equal to 126 gram. How much it is? It is 126 gram. So, 1 mole of sodium sulfite is having a mass of 126 gram. So, I can write here 1 mole of Na2SO3 is having a mass of 126 gram. So, how much 10 moles will going to constitute? 10 moles of Na2SO3 will have a mass of 10 into 126, that is equal to 1260 gram. Clear? So, this will be the mass of 10 mole of Na2S2O3. So, what you have to remember in this question, that 1 mole of any compound will have a mass that is equal to its atomic mass or if it is a compound, so it must be equal to its molar mass. And if you want to find out the molar mass for more numbers, so what you have to do, you have to just multiply the number of moles with that particular atomic mass. So this is all about the mole concept here. After this question, let's move forward to our next question. Convert into mole. Now, again it is a question that is based upon the mole, and if you want to find out the number of moles of any compound, the formula is given mass upon molar mass. Clear? So, just remember this formula. If you want to calculate the number of moles of any compound, it will be denoted by small n, and it is equal to given mass upon molar mass. The given mass of a compound will be given by small m and the molar mass will be given by capital M. Okay. So, this will be the now you have to calculate the number of moles in 12 gram of oxygen gas. Okay. So, the first part is given mass is 12 gram. Given mass is 12 gram. Molar mass of O2 will be 16 into 2 and it came out to be 32 gram. Clear? Now, if I want to determine the number of moles of oxygen atom, it will be equal to n equal to 12 upon 32. If I am going to cancel this, 2 6 are 12, 2 1 are 2 and 2 6 are 12, again 2 3 are 6 and 2 8 are 16. So, it will be 3 upon 8. Clear? And 3 upon 8 is approximately equal to 0.3. So, the number of moles of oxygen atom will be equal to 0.3 mole. So, I can write here n will be equal to 0.3 mole. Now, you have to calculate the number of moles in 20 gram of water. Clear? So, the B part I am solving here. This is our A part. So, first calculate the capital M for water. For H2O, 2 into 1, that is hydrogen. For oxygen, it is 16. So, it came out to be 18 gram. Now, let's determine the number of moles here. It is given by small m upon capital M. Small m is 20 and capital M is 18. It is cancelled like 10 and 9. And it is approximately equal to 1.1 mole. Okay. So, for water molecule, the number of moles will be n equal to 1.1 moles. So, this is our B part. Now, let's move to the third part. You have to calculate the number of moles in carbon dioxide gas. So, firstly, we will determine the mass of carbon dioxide. So, the third part I am solving here. This is our C part. Molar mass of CO2. For carbon we have 12, for oxygen we have 16 and it will be equal to 12 plus 32 and it will give you 44 gram. Clear? Molar mass of CO2 will be 44 gram. Now, what you have to determine? We have to calculate the number of moles. So, again n will be given by small m upon capital M. Now, what is the value of small m? Small m is 22. And what is capital M? Capital M is 44. So it will be 22 1 are 22 and 22 2 are 44. And what is the value of 1 by 2? We will get n equal to 0.5 mole. So n came out to be 0.5 mole here. So it is very easy to determine the number of moles of any compound just by dividing the given mass with the molar mass. So just copy this question from here so we can proceed to the next one. Now let's move to the next question. What is the mass of 0.2 mole of oxygen atom? Again, the simple questions based on the mole concept. So you can see that how much important the mole concept is. So you have to determine the mass of 0.2 mole of oxygen atom. So I have just told you that 1 mole of any compound will have a mass exactly equal to its atomic mass. Clear? So just remind this simple formula. 1 mole of any compound having a mass that will be equal to its atomic mass. So this is the key point you have to remember for solving these problems. So this is the formula that you have to keep in your mind. This is again important one. Now we have to determine the mass of 0.2 mole of oxygen atom. So first part I am solving here. 1 mole of O2 atom have a mass equal to 16 gram because O2 will give you the 16 gram and we want to determine the mass of 0.2 mole of oxygen atom. So mass of 0. mole of O2 atom, it will be equal to 16 into 0.2. Clear? And it is equal to 3.2 gram. 16 into 0.2, it will be equal to 3.2 gram. Clear? Similarly, you have to calculate the mass of 0.5 mole of water. So, let's do the second part. Mass of 1 mole of water. The mass for 1 mole of the water is 18 gram. How much it is? It is 18 gram. And we want to determine the mass for 0.5 mole of water. So, mass of 0.5 mole of water will be equal to 18 into 0.5 and you can see this will be like this. Point is shifted here, 5 1 are 5 and 5 2 are 10 and 2 9 are 18. So, it is equal to 9 gram. Okay. So, what you have to do? You have to just multiply the atomic mass or molecular mass with the number of moles given. So, this is the answer for our first part and this is the answer for our second part. So, just copy this from here. Now, let's move forward to the question number 10th. Calculate the number of molecules of acid present in 16 gram of solid sulfur. So, any number of molecules that is present in a given mass of a compound will be exactly equal to its Avogadro number. So, if I am saying that sulfur is having a mass of 32 gram, so this 32 gram will consist of the number of molecules that is equal to the Avogadro number. Clear? So, again you have to remind of one simple point. For a given mass, for a given atomic mass, number of molecules will be equal to Avogadro's number. And what is the value of Avogadro number? The value for Avogadro number is 6.02 into 10 raised to the power 23. So, this is a key point you have to remember here for solving numericals. Now, the question is you have to calculate the number of molecules that is present in S8. Okay. So, firstly I am calculating the mass of S8 molecule. S8 means 1S is equal to 32 gram. Okay. So, it will be equal to 8 into 32. So, it will give you 256 gram. Now, the question is 16 gram of sulfur is having a molecules that is equal to Avogadro number. So, number of molecules in 16 gram of sulfur is equal to 6.02 into 10 raised to the power 23. This is the number of molecules in 16 gram of sulfur. On what we have to determine, we have to calculate the number of molecules in 256 gram of sulfur. So, we will apply a unitary method here. Now, what is the unitary method? This thing will be written here. This thing will be shifted in denominator. And this thing will be go in multiplication. Clear? So, this is the equation we are getting here. Now, what we will do? We will simply cut this equation. So, 2 8 are 16, 2 1 are 2, 2 2 are 4 and 2 8 are 16 again. 8 1 are 8 and 8 6 are 48. Clear? So, this is what I am getting here. Now, 16 is going to be multiplied with 6.02 into 10 raised to the power 23. This will give you the number of molecules in S8 molecule. So, it will be equal to 6.02 into 16. So, for a given atomic mass, the number of molecules is, so we can correct here. This is the 256 gram here. So, just do a little correction here. It is 256 gram here and it is 16 gram here. So, it will be just by applying unitary method, it is 6.02 into 10 raised to the power 23. It will be 256 and it is equal to 16. Now, on solving, I will get 128. Here I am getting 8, 8 1 are 8 and 8 6 are 48. After simplifying with 2, it is equal to 8, 2 8 are 16. It is equal to 3.01. Okay. So, it is exactly equal to 3.01 into 10 raised to the power 23 and here I am getting 8. Clear? So, when 8 is divided by 3.01, what you will get here? You will exactly get 0.38 into 10 raised to the power 23 atoms. Sorry, it is molecules here. So you will get 0.38 into 10 raised to the power 23 molecules, or you can simply write 3.8 equal to 10 raised to the power 22 molecules. Both the answers will be correct here. So this is how you can calculate the number of molecules of any compound just by simplifying it with the Avogadro's number. Okay. So now let's move forward to the last question of your NCERT, that is question number 11. So what the question number 11 is saying? This is question number 11. You have to calculate the number of aluminium ions. The question is, calculate the number of aluminium ions that is present in 0.051 gram of aluminium oxide, and the mass of the ion is same as that of the atom, and the atomic mass of aluminium is 27 gram here. So what you have to do? Firstly, calculate the molar mass of Al2O3. So let's determine the molar mass of Al2O3. Now, aluminium is 2 and mass of one aluminium atom is 27. Oxygen is 3 and the mass of one oxygen atom is 16. So, it is equal to 54 plus 48, and you can see it came out to be 108 U. U is the atomic mass unit. Now, you have to determine the number of aluminium ions that is present in 0.051 gram of aluminium oxide. So again, the number of ions present in the given atomic mass of a compound will be exactly equal to its Avogadro number. So you can write here 108 gram of Al2O3 have ions that is equal to 6.02 into 10 raised to the power 23. So similarly, 0.051 gram of O3 ions will be, again applying the unitary method, 6.02 into 10 raised to the power 23. This is what we have calculated the molecular mass here. Upon 108, and this is 0.051. So it must be go in multiplication. Clear? So this is what we are getting here. Now 6.02 into 10 raised to the power 23 upon 108 into 0.051. So if you shift the point, there will be 1000. Clear? This is how what we are getting. So now it is equal to 6.02 into 51 upon 108, and you can see that 3 zeros will be cancelled by 3 zeros and you will get here 10 raised to the power 20. Clear? This is what we are getting here. On solving this, what we are getting here, let's do a simple calculation. So this is the mass what we are getting for Al2O3. It is 2 into 27, 54 and 48. So what we will get, 54 plus 48 will give you 102. So it is 102. This will be changed to 102. Okay, this is how what we are getting. 51 1 are 51 and 51 2 are 102. If 2 is cancelled by 6.02, I am getting here 3.01. So you can see the number of ions you are getting is 3.01 into 10 raised to the power 20. But what we have to determine? You have to determine the number of aluminium ion. And you can see that in the formula of Al2O3, you have 2 atoms of aluminium here. We have 2 atoms of aluminium here. So number of ions in atoms of aluminium, it will be equal to 2 into 3.01 into 10 raised to the power 20. Clear? So it came out to be 6.02 into 10 raised to the power 20 ions. So this is the answer what we will get for the number of aluminium ions. So this is how again the question is based on the Avogadro number. If you want to determine the number of ions, number of atoms, what you have to do? You have to simply put the atomic weight equal to its Avogadro number and you can find out the whatever the given in the question. Okay. So this lecture is over here. We have completed the NCERT questions of atoms and molecule. We will deal with NTSE questions in our next lecture. Thank you so much and have a wonderful day.